Howdy, all. I think I am live, but for some reason it is not showing me what I want it to show, which is essentially the chat, so that I can, see if people are, responding to me. Let me do this the old fashioned way and go to. Apologies, all, again, as always. Tech. Really, though, it's more day job interfering with the amount of prep time that I need to tech properly. Let's see here. Well, it says I'm live, I think. Ah, yeah, I do appear to be live. All right. You are live. Howdy, Judy. All right. Let me see if I can do this. Nope, that's not what I wanted to do. Nope. How do I pop this thing out? There it is. Okay. Alrighty then. Haha, I think we can actually get started. I am Professor Parks, PhD, and I do content on astronomy, science skepticism, and mental health. First thing that I would like to do is, or at least to say, is that I know that occasionally I have, well, possibly more than occasionally, I have been bemoaned my low sub count. But what I should be doing is celebrating having an awesome community who actually stands behind me on this, because someone in that community, I related that I needed a boom mic or a boom arm for my mic, and lo and behold, money appeared in my Patreon, or money appeared in my PayPal, and boom, I got one. So that is awesome and a huge responsibility. So hopefully I will make sure to keep my requests relevant. Now, hopefully, I am seeing that I am buffering or doing whatever. My frames per second are dropping out. I don't know why. Probably because I have so many things running on this laptop that it's pathetic, and I need a new laptop. You hear me, GMU? I need a new laptop. Sadly, you're not going to give me one for another no, I think it's a year. I think I got one more year left. No, Ian, is not in fact a new mic. It is a new boom mic, or boom arm, and so now it is off my table. So whenever I hit my desk, it doesn't sound like there's a huge boom. So howdy. Let me go through the list. Howdy, Charlie. Howdy, Judy. Georg, Meraki, Ian, PhD Tony. I'm so glad you're here. Clive, I always blame Elon Musk. Clive, thank you, Nerd Alert, for the €2.49. Is it cents? So you got the euro, but if you go to less than a euro, is that cents? I don't actually know what that's called. So yeah. Howdy, Eric. Eric is actually the person who brought this individual that I'm going to discuss to my attention. And howdy, little professor. He did so by posting this on Blue Marble Science's Discord. And this is the first time I've ever really done this, to my knowledge, where I'm going to try to kind of in real time go through a video and not exactly debunk it, but really just comment on it. And the reason for it is this gentleman, as far as I'm aware, is in fact a PhD holding geophysicist. So let me do this. His name, which I am going to absolutely butcher, and I'm probably going to lose the chat. Yes, sense. Okay, I thought so. His name is Alfonso Alfonso de Vasconcelos Lopez? Alfonso Lopez. I think I can manage that. This is the page that I've found. He is a... Oh man, I really wish I could... Let me see if I can do this. I don't need that to be full screen now, do I? Here we go. We can bring this over here. This is from a virtual library. It states that Dr. Lopez got his doctorate in geophysics from the University of Sao Paulo, and he worked for 3 years as a DR3 autonomous PhD professor at the university with the seismology group. Now, this is why I wanted to approach this, or to approach this subject, or at least this guy, in that he put out a video, which is posted again on Blue Marble Science's Discord. So if you're a part of that Discord, you can go find it. And it's essentially his introductory video where he describes how he transitioned over to flat Earth. And I know this is going to shock many, many people, but the reason he changed his mind, or the reason why he went to flat Earth, was because of YouTube videos. Yes, we have a PhD who is who has moved, a PhD geophysicist who, by his own admission, has moved over to the flat Earth because a friend of his challenged him to explain a flat Earth video, which by his account he did easily. The second video he challenged and was able to explain easily, and then at some point, 3 or 4 videos down the line, he couldn't come up with an explanation. He could not debunk it per se. And what was it that he could not debunk? Seeing too far. I can't remember the exact. I can't remember the exact scenario. I don't know if he was specific. Oddly enough, in his first video, he is remarkably vague as to what specifically he was looking at, which videos he was looking at, who was the person who was challenging him in the first place. There's a lot of just vague kind of responses to it. He does admit in that video that it is his opinion that the Earth is flat, that he at the time had not looked into the science of it well enough to confirm that the Earth is flat. So from a scientific point of view, I guess he was ambiguous. Now, I am not a geophysicist. I know almost nothing about seismology. But I will have to defer to PhD Tony on this, but I believe in order to make sense of seismology, one has to not assume, but the Earth must be a globe. I do not know how seismology could work on a flat plane, because, from my limited and naive standpoint in terms of seismology comes from the fact that the Earth is very geologically active, comparatively speaking, underneath its crust, and it is through that motion of magma underneath the lithosphere, which has cracked the motion of the mantle, which has cracked our lithosphere into plates, and through the irregular motion of the mantle, This causes these plates to move relative to each other. Friction primarily keeps them in place, but every so often the pressure builds to the point that it overcomes this friction, and wham bam, you get an earthquake. I do not know how one could explain this using flat Earth, which I found to be very curious in his introductory video, because he did not discuss that at all. He reminded the audience, his audience, 4 or 5 times that he is in fact a geophysicist. Yet he did not mention any sort of geophysics justification for his transition. Now I found his CV. I'm going to go to the bottom of it because just above this is his personal information, and I do not wish to dox him in any way. I don't know if you can actually see this very well on here, but it says that he got his PhD in geophysics in 4 years from the University of Sao Paulo. His doctorate, his dissertation is local mechanisms and lithospheric efforts in Brazil. He wrote it in 2008. His advisor is Marcelo Sampaio. Yeah, I am horrible at this. Now, his job rating, this is probably an outdated CV. At least I hope so, because it only goes up to 2008. It talks about, and it's later in his PhD career, in 2007, he did something where how to create a business plan. In 2008, self-development, becoming an effective leader. And in 2008, he also lists employee for support service for micro and small businesses in Sao Paulo. Yeah, I'm not entirely certain if he even works in the field of geophysics at the same time, at the current. But he is published in, from what I can see, reputable journals. One of them is Geophysics and Computers. The other one is the Geophysical Journal. I think they're listed. Down here, or some of them are listed down here. Yeah, Computers and Geosciences, Geophysical Journal International, Journal of South American Earth Sciences. Again, Tony would have a better understanding of how reputable these journals are, but they look pretty. They look intriguing to me, particularly this one, which is a genetic algorithm inversion of the average 1D crustal structure using local and regional earthquakes. Why it's interesting to me is that I have used genetic algorithms in the past in use of interferometric image reconstruction. Tony states, there are flat Earth seismological specialists who work in exploration. Okay, all right. Love to hear more about that. But what we are doing here today, and hopefully I can do this and not get flagged by YouTube for fair use and all that kind of good stuff. But hey, since I do not have ads, why the hell not? Let's do it. So, I'm not going to show the introductory video. Yes, interferometry requires a container. I think earthquakes also require a container. At least seismology does, from what I've been told. I'm not going to show his introductory video. Like I said, if you're on Blue Marble's channel, you can watch that. Again, it's not a interesting watch to me, because again, it's simply just explaining his. It's a what are the people who testimonial, I think, is those who have been saved. When they talk about being saved by Christ, they stand up and they give I think it's called a testimonial. That's essentially what this is, or what that was. This is on a channel that has 4 subs. Finally, someone who has less subs than me. It was posted 5 years ago. So again, I don't know how active this guy still is. But I'm. This was the original video that was posted was by Taboo Conspiracy, who is highlighting this dude as a geophysicist who says the Earth is flat. So I saw that. I had to investigate it. So I dug deeper. Again. All right. So those journals are. So Geophysical Journal International is a major geophysical journal. Okay. Where was I going with this? So yeah, Taboo Conspiracy put out a video highlighting this individual. So I don't know how much he has made the rounds in terms of the flat Earth community, but I am very much intrigued as to how someone who has a PhD in geophysics why they would subscribe to a flat Earth model. And as it turns out, he doesn't state it explicitly, but later on you'll find that he basically references the Bible. So I think his justification for it ultimately is a divine one. But he also talks about his model is actually from Old Hebrew, according to him. He also talks about yin yang, so it's a little weird. Yeah, Eric, don't spoil it. He is, his big thing is plasma. So hopefully I will play this. Let me know if the sound is good.
Modelo de terra plana, que é modelo que
Again, he's speaking in Portuguese,
faz muito tempo que não é utilizado, as observações não foram feitas para ele, então é um modelo pouco conhecido, né? A gente tem várias dúvidas sobre o modelo terra plana, e existem vários modelos de terra plana. Eu vou apresentar para vocês um dos modelos, que é um dos modelos que eu estudei para essa questão da inversão do campo magnético. Mais para frente a gente pode falar de outros modelos. Também tem modelos interessantes no globo. Agora, responde todas as perguntas o modelo do globo? Não responde. Este modelo que eu vou apresentar é...
Okay, so in case you didn't hear it, although, like I said, he's speaking Portuguese, so you can, basically have to read the subtitles. Anyway, although I don't know if he speaks English. He seems to indicate that he can read it later on in the video, but again, that could just be scripted. And so let's just stop it there. And so what he's pointing out is a couple of things. One, he talks about the magnetic inversion theory. I'm coming at this a little bit blind, as it were. I've watched this video all of once. In my recollection, he does not talk about magnetic inversion. He does talk about the Earth's magnetic field, which will interact with a plasma, but it flipping, he does not address in any way whatsoever. But what I find to be very interesting is that he acknowledges that there are multiple flat Earth models. This was 5 years ago. So this was, 2019? So he recognizes there are multiple flat Earth models, but he is going to he has latched onto this one because he believes that, quote, this model that I'm going to present answers to all... paraphrase. This model that I'm going to present answers all outstanding questions. And he is claiming that that the globe models do not or cannot. It sounds like gibberish, but not Portuguese. I'm going with Portuguese because he's Brazilian, presumably. He states that the globe model has not an answer for every question, which I suppose is accurate. I don't think of any scientific model that can answer every single scientific question that we have, because that would be strange. But apparently this one can. Keep that in mind as we move forward.
Ele responde todas as perguntas, então é muito interessante, tá? Então hoje a gente vai falar sobre o Sol, o plasma, o domo, da Terra e o campo geomagnético. Agora, qual que é
Tony, I hope the doctor's appointment goes well. And yeah, if you want to revisit this, I would love to hear your thoughts in the comment section.
palavra do dia? A palavra do dia é essa aqui, ó. Plasma. Tá?
Plasma.
Vamos lá. Por que a gente vai adotar um modelo de terra plana? Bom, principalmente porque ele responde várias perguntas que os outros modelos não conseguem responder, ok? Agora,
I don't know who Lindsay is.
também é óbvio, né? Isso aqui é vamos dizer assim, um navio viajando no globo, tá? As crianças sempre perguntam sobre isso, né? Como é que o navio fica de ponta cabeça lá no Japão, né? Lógico, o Japão na verdade não está de ponta cabeça perto do Brasil, os dois estão de lado oposto, todo mundo está na perpendicular, né? E na verdade no modelo
I wanted to pause it here to acknowledge my own northern bias, which is that when I first saw this and he said, why would a ship be upside down in Japan? And I was like, it wouldn't be upside down in Japan. And then I realized, oh yeah, wait, he's from Brazil. So yes, it in fact would be upside down. So yeah, as to what children are asking this in, I have no idea. But just to kind of move it along a little bit again, not to tempt fair use, he admits, he recognizes that with the globe model, shall we say, that we are talking about, this is explained through that there is no up and down per se, there is only towards the ground and towards the sky. Let's just run it.
E para cima do centro, né? Mas a gente vai adotar um modelo de terra plana, um modelo hebreu de terra plana, que a gente vai falar um pouquinho mais para frente, né?
It's unclear to me
Aqui
as to his position
só
on
uma
gravity.
questão para quem ainda gosta do modelo do globo. Vocês já viram um equipamento de levantar peças pesadas com vácuo? Pegar uma peça de não sei quantos quilos, ver uma mão com um vácuo, encosta.
So he is now going to demonstrate his apparent misunderstanding of how a vacuum works, or how gases operate in a vacuum. His contention is that a vacuum sucks. It doesn't. What happens is that a gas will fill a vacuum because the pressure of that gas is more than the pressure that is within the vacuum. Essentially, things rush into a vacuum. Things do not get sucked up by the vacuum. And so he's asking, he has never seen a vacuum lift several kilos of anything up into the air.
Encosta uma peça e levanta, o vácuo ele é muito forte, né? E aí de repente a gente observa o nosso planeta globo com uma atmosfera, o universo inteiro com vácuo em volta.
He also
e esse vácuo
makes
não
the mistake
puxa
of claiming that the
terrestre.
vacuum of space is immense.
Esquisito, né?
No,
Mas
it's not
vamos
kind
lá.
of strange.
Esse é o modelo que a gente vai utilizar, o modelo antigo hebraico, e basicamente o que a gente tem.
So here is the model that he is going to present, as it's stated on the, as he states, I think it's an old Hebrew model where again you have a flat Earth which is constrained, which has a dome or firmament over it, and presumably there are, according to the diagram, there are waters above it. Now, as you can see, the sun, the stars, and the moon are contained within the dome. I don't believe he does talk about what the sun is, and he does talk about what the moon is later. He doesn't address the stars. He does not address space. So I don't know, again, as far as I remember, he has not put forward his explanation as to whether or not these things are real or not. He does believe that there is something above the firmament. So yeah, I don't know what that is. He also doesn't talk about the Great Deep. He also doesn't talk about Sheol. So, yeah, he basically is really just going to be focusing in this video on the dome, what the dome is, which actually is kind of impressive in the sense that he tells you what the material of the dome is. So, but I'll let him go forward.
Tá um pouquinho diferente do que a gente vai utilizar, mas a gente tem um domo, tá? A gente vai falar sobre que material é esse domo. A gente tem este tubo aqui em cima, esse chamado de portão para os céus, tá? Um portão. Tem várias culturas, o pessoal fala sobre esse portão que tem aqui em cima, que na verdade é como se fosse um tubo de luz, que a gente vai comentar. E aqui dentro a gente vê uma luz.
There are several cultures that talk about it. Citation needed. I know of no culture that talks about a giant tube in the sky. Unless you're talking about the great religion of Disney and the Book of Marvel, which seems to have a plethora of sky beams within its pages. Outside of that, I don't know of any culture that actually talks about a hole in the sky.
Luz muito forte, que é o Sol, e a Lua, né? E depois a gente tem basicamente as águas aqui embaixo e os continentes e tudo mais. Agora, olha o que é interessante. Vamos lá. A Terra tem um campo geomagnético. Isso é mensurável. A gente tem medidas no mundo inteiro sobre esse campo geomagnético. E ele varia um pouco, ok? Agora, a água, ela tem uma propriedade que se chama ela é diamagnética, ok? Ela é repelida por campo magnético, ok? Ela é repelida por um ímã, por exemplo. E aqui está um exemplo, um ímã na água e ele está repelindo a água, ok?
He does say okay a lot, but as I say so a lot, I can't
da
really
Terra
judge.
plana que a gente vai utilizar, o campo geomagnético da Terra, que está fazendo as linhas.
Okay, here what he is going to talk about is, I guess conventionally when you look at ice, you find that the ice is flawed or is not is opaque to some extent. So the bottom right image, you have ice that has been frozen quickly, and so you have the air bubbles that were in the contained within the water in liquid form basically get trapped, and that causes the opacities, the inclusions that you see, so you can't see through it. So, for again reasons that I don't know, he does not go into, because by the model he presented, everything is within the dome. He is making a claim that the dome is in fact clear water, or clear ice, excuse me. And the way that you would get clear ice is through a slower process. I don't exactly know what he talks about in the this example, but essentially, instead of just putting water into a freezer, what you want to do is you want to put water within a foam container, and so the water freezes more slowly, the air has more time to escape, and it becomes clear, as you can see in the upper left.
Da nossa geladeira. Ele não é um gelo com bolinhas brancas, que nem este aqui, tá vendo? Ele não tem.
Yes, Professor, that's why I'm going over this. Is that he
ele
has
é um gelo igual a este. Transparente.
degree
Tem
in
bloco
Geophysics,
de gelo aqui na frente
a PhD
do produto, um bloco de gelo espesso, e dá para ver do outro lado. Por quê? Porque ele foi congelado lentamente. Para quem quiser fazer um bloco de gelo como este aqui, congelado lentamente, o que você faz? Você pega a sua forminha de gelo, tá? E ao invés de colocar diretamente no freezer, você coloca ela, o gelo fica mais quebradiço. E o gelo sem o ar lá dentro, ele fica mais firme. Ok, ponto. Então o que acontece? O campo geomagnético, nesse modelo, empurrou a água para cima e criou um domo de gelo bem espesso, tá? Não tenho ideia da espessura, mas é bem espesso. Criou esse domo de gelo em cima do planeta. Que seria então, no nosso modelo da Terra plana, seria este domo aqui, tá? Beleza. E aí a gente vai ter que falar sobre o Sol. Então,
okay, so a couple things here, because he is now he is effectively done with describing why the dome is a dome. So just to recap, and again, those of you who are watching now or in the future, you can correct me if I'm getting this wrong. But what he seems to be implying is that the Earth's magnetic field has coupled with water, presumably water vapor, that is in the atmosphere, and has caused and is rising, and is pushing that water vapor up, and in that process you have a slow freezing, which creates a thick dome, a dome whose thickness he does not know, nor does he even guess as to what its actual thickness is. But that is that's what the dome is. The dome is, in fact, a large, thick dome of water ice. Let's see. PhD Tony, there are models used in mineral exploration that treat the Earth as flat and invert for subsurface properties like seismic velocity or conductivity. Interesting. Okay. Well, that might be akin to how we used to address, although probably still do to a large extent, when we're talking about stellar atmospheres, which I can't wait for, folks like Whitsitt and Alan to get a hold of that, in that when we treat stellar atmospheres, when we try to understand the energy transfer through the photosphere and the lower corona, we treat it as plane parallel. We actually treat the sun as being flat. So I'm wondering if that's akin to it. The reason why we treat it as flat is, one, it's a reasonable assumption to make given a small enough spatial scale, and the other reason primarily is that adding another dimension is wicked hard and actually requires supercomputers in order to do it right. So it's really more of a, this is the best we can do with getting as good an answer as we can do in 2 dimensions using the resources that we have. So it seems to work out. Howdy Blue, I was talking up your Discord channel before. So yeah, there you have it. Folks, the dome is caused by the dome is solid water ice that has been frozen slowly so that it is clear. Why it has to be clear, I don't know. I suppose because we don't see inclusions in the dome, that's why it has to be clear. Now, questions that I have are, was this a singular process? Is this an ongoing process? So it required the magnetic field of the Earth to repel water vapor, although he doesn't specifically say water vapor, he says water. I'm presuming that he means water vapor. It repels the water vapor upward, and then once it gets to a high enough atmosphere, or altitude, he does not state this, but once it gets to a high enough altitude, it will freeze into this dome. Now, my question would be then, is this dome stable? Meaning that, does it not melt? He does imply, or he does state that clear ice does not melt as quickly. So, he doesn't melt, and so therefore it needs to be replenished. For me, this sounds very similar to how solar prominences form, where through the convective action of the upper envelope of a star, a magnetic field of the sun, which is frozen into the plasma, will become buoyant or buoys up and comes up off the surface of the photosphere, and that magnetic field is strong enough that it attracts hydrogen ions or protons and electrons, and it basically starts that gas, that plasma condenses onto that magnetic loop and rains down that plasma back onto the surface. That's what I'm familiar with. That's when he talks about this, that is what's going through my head. So is that what he's talking about? Is this a dynamic process, an ongoing process, or not? And yes, I know I am probably overthinking the shit out of this, but these are the questions that need to be answered, folks. These are the burning questions that I need answers for. So yeah, is this an ongoing process? My other question is the, again, not entirely certain what the current strength of the Earth's magnetic field is, but I'm fairly confident it's extremely weak in comparison to, say, your refrigerator magnet. So why is it that, or how is it that the Earth's magnetic field is strong enough to do this? I'm assuming he does not make any claims as to what is supporting the ice dome. He does say that it is extremely thick, although he does not, again, specify how thick. So I'm going to make the assumption that it supports itself through its own structural integrity, very much like an arch does, or any other type of dome. So yeah, how is the magnetic field strong enough to force water to go high enough to form this dome, and yet not interact with any sort of ferromagnetic material or really anything that would, any other diamagnetic gas or what have you? So why is it that we do not see the magnetic effect elsewhere in this, on the Earth? And if we do, then what is it? Maybe I'm missing something. Maybe there are observations like helium balloons. Maybe the reason why helium balloons float is because they are, in fact, magnetic sails. I'm not entirely certain, but this isn't the funnest part yet. The funnest part for me is when he gets to the sun. Is his explanation for the sun, which I have to say is a lot more what's the word I'm looking for? Novel than Dr. Robitaille's explanation for what the sun is. And eventually, yes, I will be doing this sort of treatment with Dr. Robitaille.
A gente já sabe que é domo de gelo puro, limpo, sem bolhas nem nada, que formaria a cúpula ou domo da Terra, tá? Neste modelo que a gente está conversando. A gente pode falar sobre trocentos modelos, mas esse modelo é o melhor que eu encontrei para explicar as coisas. Ok, esse modelo não, né? Não um Sol aqui, mas agora a gente vai falar sobre o Sol. Esse aqui é o Sol convencional da ciência, tá? Essa bola enorme de fogo seria o Sol, e esse pontinho minúsculo aqui, ó, seria, não sei se vocês vão conseguir ver, tem um pontinho minúsculo que é a Terra, e aqui tem um ponto invisível que é a Lua, tá? Então esse pontinho minúsculo seria a Terra, e aqui tá vendo uma labareda do Sol? Uma labareda enorme? Essa labareda é muitas vezes, dezenas ou centenas de vezes.
That blaze is known as a solar prominence. I was just talking about that, and yes, he does get that correct. Solar prominences, such as that one that we see, that he has presented there, can be many times the size of the Earth.
Maior do que o nosso planeta no modelo convencional, ok? Pronto. Então esse aqui é o modelo convencional, mas isso não é o Sol do nosso modelo, tá?
It is not the flat Earth sun.
Então, de novo aqui, mais uma imagem do Sol convencional do modelo que...
That is not an image of the sun in the model. He seems to be implying here that this is a modeled image, as in that this is a model which has been, or this is an image that has been generated. That is incorrect. This is I don't know where this image is from, and I cannot state to this particular image, but you can easily find images that are akin to this on the Soho website, the SOHO, which I have. The last O is observatory, H is, I think, helio something. Yeah, I don't remember what it's called. Soho is a satellite that's been monitoring the sun for decades at this point. You can find images like that on here, and they are not computer generated.
E é adotado nos dias de hoje. Para vocês terem uma ideia, ó, uma chuva de plasma do Sol tem velocidades de 200 mil quilômetros por hora.
He seems to be reading English.
Uma gota dessa chuva de plasma que tem no Sol é do tamanho de um país.
Oh, in the English blurb, that country is Ireland.
Esse modelo, ele implica em dimensões enormes para o Sol. O nosso modelo não. Então,
So, this I also find to be interesting. If you missed it, because I was talking about the droplets being the size of Ireland, he seems to laugh at the idea that the solar model would have droplets of plasma that are the sizes of countries like Ireland. It seems I am interpreting this as he is rejecting this idea because big numbers. He because of the size. The size is too large for him. I don't want to go too far into this because, again, this is all my own interpretation, but the fact that he laughed while talking about how the conventional science states that these plasmas are moving at 200 kilometers per hour and they are the size of the sun, I can only assume. And so, again, for someone with a PhD in geophysics, the idea of big things being funny to him is interesting to me. So, I don't know. And yeah, I don't know what the compression strength of ice is, but apparently maybe this is, I don't know. I also just learned that ice has ridiculous, like 10 phases. Like there's apparently phase X ice, which is presumably at the bottom of Europa's ocean. I don't know. Apparently there's a lot about ice. I had no idea about it. Sizes do sound astronomical. Yes, they do.
Sol convencional de novo. E aqui vem o fato, né? O Sol como a gente observa, né? Com a devida proteção para tirar uma foto, etc. Tal. A gente até vê manchas solares, né? Mas isso aqui é o Sol e isso aqui é o que a NASA mostra pra gente que a gente não consegue ver.
This is perhaps the most egregious portion of his video. Although now that I'm reading it a little bit more carefully, maybe I can give him something of a benefit of the doubt. What he's basically stating is that the top image, with proper protection, you can see that using what he refers to as a regular telescope. And that is true. That is what we refer to as a white light image of the sun. If you have been following my channel, particularly my community posts, I have been posting a lot of those. I've been using my C-Star. Thank you, patrons, for helping me purchase that, and channel members for helping me purchase that. Specifically, channel members, actually. But anyway, I have been using that to observe the sun every chance that I can, that my schedule and the weather will allow. And I have been taking, and they look very much like that. You can see the sun looks orangey. You can see the limb darkening. You can see sunspots, that sort of thing. The image on the bottom, which he does not talk about, is, or does not describe properly. He states that it is what NASA shows us. Again, here we go with the idea that the great conspiracy is that NASA is behind some kind of great conspiracy. That, in fact, this image could not have been taken by any other organization other than NASA. Now, to be fair, I don't know if the SOHO satellite is NASA-run or funded or what its connection with NASA is. I do think it is affiliated with NASA, but that being said, if you have been following this channel comes to the recent eclipse, I can show you images that I didn't take, but one of our students took using our H alpha telescope that are, while not having that kind of resolution, are very similar to that. So the bottom image, which is labeled fiction, is not fiction. That is an H alpha, that is an image of the sun taken through a very narrow band filter which centers around the H alpha emission line of the sun. Now, what is H alpha? In brief, H alpha is when the electron moves off is excited off the second orbital or first excited state. I believe it is the 2 to delta gamma 4. No. 3, 4, 5, 6. I believe it is the 2 to 6 transition. It corresponds to a wavelength of 665 nanometers, hence why it is very red. And because the because the sun is primarily composed of hydrogen, that is where a lot of activity happens. And you can see a lot of magnetic activity or activity that is born from magnetic action there. The prominences, the flares become very nice, very visible. You can't really see them in white light. Magnetic active regions, which are the precursors to things such as prominences, flares, and sunspots. These can also be seen very much more easily in H alpha. So the idea here that this image on the bottom is fiction is simply wrong. And I might go so far as to say it's a deception. Now, is it a deliberate one? Not sure. I'm guessing that with this hashtag truth to the youth, I'll say that again, hashtag truth to the THA youth. I'm assuming he is looking at this, and this is simply a meme that he is using as a prop.
Com telescópio comum, tá? Esse aqui é o tal do Sol da NASA.
My point is that if you can get an H alpha, that an H alpha telescope can be purchased by the average citizen. Granted, a good one is going to set you back a lot of money. Ours, which is a 150 millimeter aperture, is about 10 grand. But we did acquire a much smaller H alpha scope for about, with mount, for about 1,200. And it is ridiculously easy to use. And so you can use that to get an image that's not nearly as detailed as the one on the bottom, but similar to it.
E esse aqui é o Sol que a gente observa, que é uma diferença. Esse aqui é o
Both
Sol dos filmes de ficção. Esse aqui é o Sol que a gente observa, né? Beleza. E basicamente no modelo convencional tudo gira. né? O interessante disso, que eu quero que vocês marquem na cabeça, é o movimento espiral, né? Então o Sol está viajando numa velocidade enorme, os planetas estão girando em volta do Sol enquanto ele está viajando, ok? E esses planetas também estão girando em volta de si mesmo. Então tem a Terra, o planeta Terra está girando em volta de si mesmo e em volta do Sol e ainda andando com o Sol pela Via Láctea, numa velocidade enorme. Esse é o modelo convencional, não é o nosso modelo. Nosso modelo, a Terra é estacionária, plana e estacionária, ok? Beleza.
So, he refers to it as our model, meaning him and those of like mind. So, he is again affirming that he is fully a flat earther, and he has stated that the Earth is flat and stationary. Here, he is going to go into espousing that spiral structure is ubiquitous in nature. And while I don't exactly have a problem with that, he is heavily going to rely on this. He seems to heavily imply that spiral structure can be seen not just frequently, but everywhere. In fact, the bottom right, he is showing an aurora, and he is attributing a spiral pattern to it. As far as I am aware, again, I'm not an expert in aurora rarely, if ever, actually shows any kind of spiralicity or any kind of spiral nature. They appear as sheets that are curved because they are auroras are due to highly ionized particles, protons, electrons, being accelerated rapidly around the Earth's magnetic field lines. They smack into our atmosphere and do so in a very energetic way and create these amazing light shows. And the reason why they are curved is because we live on a sphere. So yeah, I do not understand why he is using aurora as an example of this. But again, perhaps the one that is, I wouldn't say egregious, but he is stating that he is backing this claim up by looking at galaxies. And he states, galaxies are, I don't know, he might say in this moment that all galaxies are spiral. If he doesn't state that, he seems to imply it. And that is just wrong. Most galaxies in our current epoch, I want to say, I actually don't know the precise value of this, but I want to say that the spiral population of galaxies comprises no more than 50% of galaxy, what we call morphology or shape. We have three general types of galaxies. There is spiral, there is elliptical, which, as you might imagine, an elliptical galaxy is elliptical in shape. It has no spiral structure to it. And then you have the irregulars. And so, current science tells us that both spirals and ellipticals form roughly from the same process. The only the key difference between what makes a spiral as opposed to what makes an elliptical is density and initial spin. He is correct in stating that, and I tell this to my students as well, is that pretty much everything in the universe rotates in one form or another. Every physical body in the universe rotates to one degree or another relative to something else. And so the proto-galactic cloud, which we theorized or hypothesized to be where galaxies stem from, that cloud has a initial velocity to it, or initial spin to it relative to things around it. And so again, it's a competition between how fast it coalesces, dictated by its density, to how fast it spins into a disk through conservation of angular momentum, which is dominated by its initial spin. So this idea that and then irregular galaxies are irregular because galaxies like to bump into each other and gravitationally tear each other apart. What I lovingly like to call galactic cannibalism. So this argument for a spiral nature to the universe using spiral galaxies as justification is just erroneous. Plus the fact that not all spiral galaxies are the same. There are, and I love this term, there are flocculent spiral galaxies, meaning that the spiral arm structure is very tenuous. And so these galaxies, they don't look like they're spinning themselves apart, but they just kind of look like they're just kind of falling apart, or were never really the density wave that created the arms in the first place weren't very powerful, and so the material kind of just we'll form arm-ish kinds of things. The Triangulum galaxy is a great example of this, if you want to see what I'm talking about in terms of a flocculent. Flocculent. My inner 5-year-old just really loves the shit out of that term. Anyway, getting back to this dude.
Tem algumas observações que o pessoal faz, aí sim, até com alguns telescópios poderosos.
Of galaxies,
galáxias
always show a spiral pattern. No, that is factually, demonstrably wrong. As I said, and I will look this up and put it in a community post. From my understanding, if we look at the number of spiral galaxies as a fraction of all galaxies, I would be very, very surprised if that number were greater than 50%. In the current epoch, in the current surrounding environment. Things change as you go to the early universe, but that is beside the point for now. The universe, how can there be a universe whirling around the Earth at so many times more than light speed? I don't know. Brian is completely disengaged, judging by that statement on the spiraling around space thing. I don't know.
Né? E sempre mostrando um padrão espiral. Esse padrão espiral a gente observa também nessas auroras boreais que acontecem no...
I noticed something here, which was, again, because I had that earlier moment of northern bias, I then am acutely aware of where this gentleman at least got his doctorate, which is Sao Paulo in Brazil. Now, I believe Sao Paulo is mid-latitudes, maybe? I don't know exactly, but I suspect it's around mid-latitudes. So it would not be expected that he would see the aurora, but, you know, there is the aurora borealis, and then there is the aurora australis, the southern lights. He does not mention that southern lights exist. And I'm pretty positive that people in, say, Cape Town and possibly Australia, or in the tip of in Argentina, they are 60% of all galaxies are thought to be spiral galaxies. I'm gonna look into that a little bit further, because as I said, that's really redshift dependent. But okay, all right. So it is higher than 50%. All right. I sit corrected. So yeah, he doesn't mention the Southern Lights, and I do believe they have been observed by things other than penguins and those NASA scientists that the armed penguins are guarding beyond the ice wall. But yeah, he doesn't mention those at all, which I, again, find peculiar because he lives or lived in the southern hemisphere. Yeah, again, I'd have to look at that, be Richard. But again, 60%, okay, 60% is definitely not all. So yeah. But anyway, now I'm gonna let this run for a little bit, but I'm probably gonna skip.
Norte, perto do Canadá, Groenlândia, o Círculo Polar, né? basicamente? A gente observa essas auroras, né? E elas têm muitas vezes esse formato espiral, okay? Como se fosse isto, mas
I would like to point out for the jury that for the members of the jury that curved does not mean spiral.
aqui no caso é o plasma que tem no centro do nosso modelo, né? Por causa do campo magnético, por causa do formato do campo geomagnético da Terra. Ok. Mas vamos guardar um pouco isso. O formato espiral. A ciência sempre mostra o formato espiral. Então, a Terra gira no formato espiral, as galáxias têm formato espiral, e quando eu falar para vocês qual que é o modelo espiral, vocês vão ficar assim, não é uma coisa trivial de engolir. Mas o que eu quero falar é o seguinte: não é absurdo quando a gente fala em espiral. Espiral está na ciência o tempo todo. Espiral, 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 espiral.
I agree. Spiral structure is seen in a lot of different areas of the universe, not only in galaxies, but you see it in nature as well with, say, seashells. So that I don't have a problem with. What I have a problem with is that he takes this to a play. He relies on it too heavily. It seems to me that he believes the spiral nature of things in the universe is far more dominant than it actually is.
Ok.
Okay.
Agora, antes de seguir mais para frente, de a gente continuar, a gente vai precisar falar sobre o conceito de plasma. Sólido, ok? Depois vem o líquido, o gasoso e o plasma. A ciência diz que este é o primeiro estado da matéria, sólido, depois você acrescenta energia, você tem o segundo estado da matéria, o líquido, depois você acrescenta energia, você tem o terceiro estado da matéria, que é o gasoso, você acrescenta energia e você tem o plasma, que seria o quarto estado da matéria. Okay? Do meu ponto de vista, isso está incorreto. Isso aqui é uma esfera, o pessoal vende por aí, com um ponto onde é feito, é colocada uma corrente e é gerado o tal do plasma dentro da esfera, com um gás aqui no caso. Tá? Beleza. Para a ciência, o plasma é o quarto estado da matéria, ele é um tipo de gás ionizado, tá? E ele representa 99,9% de toda a matéria do universo, segundo a ciência convencional. Beleza.
Sao Paulo Institute of Hair Care, yeah.
E a gente vai falar sobre isso aqui. Em um dos modelos da Terra plana, que é o que a gente vai adotar, o plasma é a fonte primária da luz do nosso Sol. No modelo da ciência convencional também, o Sol é formado por plasma, que é a fonte de luz que a gente observa aqui na Terra. A gente vai explicar isso melhor mais para frente. Agora, a questão aqui é o seguinte: se a própria ciência moderna diz que 99,9% de toda a matéria do universo é plasma.
For the record, I haven't had time to look into the veracity of his claim that the universe is consistent of 99% plasma. Yeah, the best I can figure is that what he is claiming is that 99.9% of all baryonic matter in the universe is in the form of plasma. But if that's true, again, I would be surprised if that were true. But again, I have not had the time to look into the veracity of that particular claim. If someone wants to use their Google Foo to try to figure out what he is actually referring to, please, have at it.
Pode ser o quarto estado da matéria. Na verdade, no meu ponto de vista, isso aqui está invertido, tá? O primeiro estado da matéria é o plasma, o gás é feito...
Okay, so what he is doing here is he did this before when he was discussing the four states of matter. Now, I'm not a chemist, as I have said many times before. I have avoided chemistry like the plague. I do not like chemistry, Sam I am. I do not like it with eggs, nor do I like it with ham. Chemistry sucks, in my opinion. Good for others, not good for me. I don't look at material in these terms, but I do look at matter in, which I'll get into a second. But he is correct that the difference between a solid and a liquid is the temperature of its environment. That is one key aspect of it. He is neglecting things like pressure, but let's just talk about temperature, which in this case is energy. That if you have a particular material, if you have a hotter environment, that material is going to exist in a liquid form rather than a solid form. If the environment is hotter, that liquid could that material will exist in a gaseous form. And then, again, even hotter, you get to plasma. Now, what he is implying here at the beginning, and is now flipping or inverting in his mind, is that somehow these phases of matter are connected in a sort of one turns into the other, which would sort of imply that the universe has some kind of mechanism of temperature regulation or changing of temperature to get things to be where they want it to be. I don't really know. I would not look at this with an arrow at all, really. I would not use the word add. That would be best. I would use the term increasing energy or increased temperature. So he basically is going to imply that the original state is plasma, and then it kind of condenses down into solids. Now, to be a little bit more pedantic, because I loves me some pedanticism, is that when I look at something, you have at the lowest energy state, or at the lowest temperature regimes, what you have is that atoms will arrange themselves into a structural lattice, which we label a solid. If you add heat, if you add energy, that energy, the photons that carry that energy, they're going to smack into that lattice, and they are going to break that lattice apart. Now, if the energy isn't too much, the lattice breaks apart, and the molecules which comprise that lattice, or which comprise the solace, they get to hang out, party, do what they do. If you add more energy, you get to a point where the molecules disassociate. So the energy now of these photons are large enough that they can break the binding energy of the constituent atoms that make up a particular molecule. So as he puts it here, let's look at water. So water, as we know, the water molecule, as we know, is comprised of 2 hydrogens, 1 oxygen. If you add more energy, or if you put that water into a certain energy regime, where the average photon has a certain amount of energy which is greater than the binding energy of that molecule, then that molecule will disassociate. You will have instead of having 2 hydrogens coupled to an oxygen, you will have 2 hydrogens floating around in space and 1 oxygen. And every time they try to come back together to form a hydrogen or a water molecule, they will be very quickly blown apart by the chaperone energy. So there you go. You have solid. That solid will then disassociate, or that solid can be broken up into a liquid, or rather, I think I'm skipping over that. Sorry. I'm going straight to I'm going from liquid. What I described was going from liquid to gaseous. So if you destroy the lattice, you have molecules that are swimming around that can turn into a liquid, or it can also be gaseous. Again, I'm not really concerned overly much about the difference between phases, but you get to a gas, and if the temperature is high enough, you can disassociate it. Now you have atomic gas. You have atoms in this environment that have all of their electrons in the places that they would normally have their electrons if everything was boring. What I mean by that is at the lowest energy state possible. As I frequently like to tell my students, nature is lazy. It wants these electrons, want to be sitting on the couch, drinking a beer, watching YouTube. They don't want to be excited. They do not want to carry energy. If in some way they get imparted energy is imparted to them, they will very quickly shed themselves of that energy to get down to the lowest energy state the environment will allow. So at a certain temperature regime, you're going to have a whole bunch of individual atoms flying around with their electrons orbiting around them in the lowest energy states possible. You increase the temperature, or rather, the temperature of the environment is now hotter, then these atoms get excited, and the photon will hit a hydrogen atom, for example, bump that electron up to a higher orbital. The entire atom is now energized, and then very quickly the electron will fall back down, release energy back into the system. But if the photons are hot enough and prolific or plenty enough, then it will very quickly pop back up. It will very quickly get hit by a photon, and essentially what you now have is a gas in an excited state that has observational implications. Let's keep pumping the temperature up. Let's keep finding environments that have a higher temperature. At this point, something's got to give, and that something is what we call photoionization. There is only a certain amount of energy that the atom has to hold on to their electrons. For the hydrogen atom, for example, it's 13.7 eV, or electron volts. If you hit a hydrogen atom with more than 13.7 eV, the one electron that is bound to it will break off and be free to do whatever it is free electrons do. And again, if the environment has enough of these, an electron that got bounced might fly next to another hydrogen nucleus, which is a proton, and attempt to get captured, but will very quickly smack into another photon, which will say, nope, get the hell out of here. And the electron will be free again. Unlike certain people that I could mention, New York is, I can't contain myself. New York is now my favorite state. Anyway, not going into that. So yada, 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 yada. So now you have what is known as ionized gas. And with hydrogen, you can only ionize it once because it only has one electron. But with the other elements, helium cannot be ionized twice. Iron can be ionized many, many multiples of times. There used to be, they thought that we had found a new element in the periodic table in the corona of the sun, which they imaginatively called coronium. But as it turned out, I believe it was iron 15 or something of that effect. Basically, it is iron that was 14 times ionized. So 14 of its electrons, it was hot enough that 14 of the electrons bound to to an iron atom were constantly being stripped, which is hot. You need a lot of energy to keep iron in that state. Then let's talk about extremely high temperatures. That is where you get into plasma. At this point, a plasma, as I would define it, is a material which the vast majority of the particles within it are completely photoionized. that essentially a plasma is primarily a mix of free electrons, free electrons, and free protons, possibly proton or atomic nuclei. Honestly, when I think of a plasma, I think about the sun. So yeah, primarily a soup of free electrons and free protons flying around having a good time in an exceedingly hot, dense pressure cooker of an environment. So yes, that is an in-depth way of looking at this. This simple table that he is presenting of the four elements, or not elements, four phases, and by adding energy or subtracting energy, you can change one phase into another. While technically accurate, it is simplistic from a scientific standpoint, and he seems again to be deriving meaning from it in a way that I would interpret no meaning exists. So here we go. Matter, metals plus hydrogen. Oh no. Metals. There's hydrogen. There's helium, and then everything else is metals. Google seems to confirm the claim is 99.9%. Was I correct in that the 99.9% is baryonic matter is contained as plasma? Clive Wells states around 6 to 10% of the baryons in the universe are in stars. The rest is in the interstellar medium. So the proportion that there are in a plasma state is likely to be quite low. That's what I was thinking. That was my intuition. The interstellar medium is depends on what type of interstellar medium you're talking about. There are, in a simplistic way, there are 4 regions, and this is really what I'm thinking about. I'm thinking about the interstellar medium when I'm talking about these different I was going to say phases, different ways that elements can be configured, is that you have molecular hydrogen, where you have temperatures that these are giant molecular clouds, stellar birthplaces. You're talking about temperatures that are around 10 to 100 Kelvin, and they are actually fairly dense, comparatively speaking. They are orders of magnitude, about 4 orders of magnitude more dense than the vacuum of space around the Earth. Needs to be in order for gravity to do its thing and form stars. So you have those. You can then have, if you crank the temperature, if you find an environment where the temperature is now sustained at around a couple thousand, you have atomic hydrogen gas. The hydrogen will be disassociated, but it won't be photoionized. Once you form a star, particularly like an O or a B type star, a very hot, very massive star, it will create what is known as an H2 region, where the atomic hydrogen gas, which was in the vicinity, basically gets stripped of its electrons. And you have a nearly spherical distribution of hydrogen, where hydrogen nuclei and electrons, or effectively electrons and protons. That's around tens of thousands to hundreds of thousands of Kelvin, tens to hundreds of thousands of Kelvin, and then you get into coronal gas, which is in the millions of Kelvin, and this is where things outside of hydrogen are going to be completely photoionized, like helium is going to be completely photoionized. So it depends on where in the universe you're looking, where in the galaxy you're looking. So the interstellar medium is going to be different. As to the fractions, how much of the galaxy, for example, how much of the galactic interstellar medium is in molecular hydrogen as opposed to atomic hydrogen, I couldn't say. I believe the most common species is atomic. I think most of the hydrogen gas in the galaxy is atomic in state. But as has been shown earlier today, earlier in the stream, I could be very wrong. So what else is there? According to lead scientist Bro Sanchez, blood plasma breaks the plasma model. Nice. I used to sell my plasma for cigarette money. It was a good time to be alive. I can science that, but all the plasma streaming out of the stars for several generations now, and presumably so. What fraction has built up as plasma now? I can speak to supernovae. So supernovae are critical for what we would call the galactic recycling. And so the reason why we exist is because of supernovae, effectively, for a number of different reasons. One, the heavier elements which constitute a lot of the carbon, gold, uranium, a lot of the stuff that makes up the Earth itself, that can only be generated within the furnace of a supernova or the collisions of neutron stars and black holes. Neutron stars, not black holes. Hypernovas. Neutron stars are also are also seen to, I don't know about necessary, but they definitely drive stellar formation. So stars form more quickly. But the way that these heavier elements that get formed via supernovae and via these hypernovae, which are local phenomenon, how they get distributed out towards the rest of the galaxy, is through a process by which these supernovae, generally speaking, 3 or 4, a few, will blow up. They are slightly higher in the disk lower in the disk than the midplane, so that when they blow out in a roughly spherical distribution, the lower part or higher part is in fact less dense, and so that plasma can then stream outward from the disk, balloon outward basically like a mushroom cloud, and then cool, and then fall back into the disk due to gravity. In that process, it will cool down. Some of it will turn into atomic hydrogen. Some of it will stay in atomic hydrogen form, and some of it will return to will get trapped. Will either turn into molecular hydrogen or get trapped within molecular hydrogen clouds. So. Quickly says that hits say that some is ionized, but haven't found any numbers yet. All stars form out of a fairly uniform density of neutral material. Only a small portion has gone into stars. Fairly uniform density? I guess that's, I suppose that's true. There has to be inhomogeneities or stars wouldn't form at all. But yes, Neil deGrasse Tyson, one of his arguments against intelligent design is that a giant molecular cloud, only about 3% of its mass will actually go into generating stars. But anyway, let's get back to this dude. Wrong screen. Let's try this again.
Feito de plasma, quando você reduz a energia.
Sovereign Soul, Unchained Mind, damage control.
Plasma em gás, aí você reduz líquido e depois sólido. O quarto estado da matéria seria o sólido. O primeiro seria o plasma, tá? Agora.
So yeah, again, here he seems to, there seems to be a hierarchy of states. I can't remember exactly. I was looking for what he specifically states.
Plasma. O gás é feito de plasma, quando você reduz a energia.
First matter state, that's what it is. He claims that plasma is the first matter state, whatever that means. So again, he seems to be implying that there is an order to things, that gas or material starts out as a plasma and then changes into others. I at least don't believe that's accurate. Again, in terms of how stars, how galaxies evolve, particularly in their stellar format or stellar populations, this is a cycle. This is not a going into the other. Sovereign Soul, a volume of gas will never form into a continuous mass. You ever frozen anything? You really want to go with that? A volume of gas will never form into a contiguous mass. That's what you want to go with. Okay.
Plasma em gás, aí você reduz líquido e depois sólido.
Fourth matter state is solid. First is plasma.
Seria o plasma, tá? Agora, por que tem essa importância o plasma? Beleza. Neste modelo aqui de Terra plana, então a gente tem um domo que é feito de gelo, um gelo bem transparente, espesso e transparente, bem rígido, tá? Esse gelo foi... a água desse gelo foi levada para cima pelo próprio campo magnético da Terra, porque a água ela é diamagnética.
Sovereign, your statement, quote, a volume of gas will never form into a continuous mass. Frozen is a solid, not a gas. You said a volume of gas will never form into a continuous mass. A continuous mass would be a solid. So, unless you want to clarify what you mean by form in what a contiguous mass is, if you want to clarify that, then yeah, please go ahead and do so.
Ela sofre repulsão com o campo magnético e aqui em cima tem um tubo que é chamado de tubo de luz de plasma, que é o equivalente a esse portão dos céus, aonde tem uma espiral de plasma aqui em cima, tá? Girando, que não entra aqui dentro da nossa atmosfera, e esse plasma que está aqui dentro girando, ele produz uma luz, tá? Como o plasma ele é ionizado e ele responde de forma muito forte ao campo geomagnético da Terra, esse plasma é mantido muito acima do domo. Esse plasma ele não toca no nosso domo. Ele fica lá em cima. O campo magnético da Terra empurra esse plasma lá para cima. Ele está bem mais para cima que o domo, ele não chega a tocar o domo. Ele está bem acima. Ok.
Okay, so this returns to one of my questions, and he seems to, actually a couple of my questions, in terms of the Earth's magnetic field with regards to this plasma that he's talking about. The questions before that I was having is, he seemed to indicate, and again, if I am wrong, if I am misconstruing what he is saying, please let me know in the comments, or if you're here, let me know live. And so what he is stating is that the ice dome, the thick ice dome of indeterminate thickness, is created by when the plasma, or when the magnetic field, interacts with diamagnetic water, I'm assuming water vapor, and that pushes it up to high altitude, which, again, this is an assumption based on, because he's not specific, pushes it to a high altitude, and that water vapor freezes into this thick dome. Now, apparently, the plasma is, or the magnetic field, is now above the dome and has created plasma somehow, or rather, the plasma exists up there somehow, and that the magnetic field of the Earth is He says, and this could be a translation issue, he says the magnetic field of Earth pushed this plasma up well above. So that would indicate that the plasma was formed lower and has been moved to a higher altitude, as opposed to existing at a higher altitude and being maintained by the presence of the magnetic field of the Earth. So if that's the case, if the plasma is being pushed, basically where is plasma? Where is camera? Where is the plasma being formed? Because as he already indicated, a plasma needs an extremely high temperature environment in order to exist. Now, you can alleviate, you can lower the temperature needed for it to exist if you greatly increase the pressure. This is the sort of the methodology behind trying to figure out the puzzle of cold fusion, which incidentally also uses magnetic fields. But this plasma has to be created somewhere. And to be pushed up. So where in this model is the plasma being formed? Because what I'm getting to is, if it's formed below the dome, then how does it not melt the dome as the magnetic field pushes it upward through the dome? If it's above the dome, as he's stating here, because again, as he recognizes, the plasma, if it touches the dome, will melt it, what is creating that temperature environment such that the gas, which is there, again, he doesn't specify what this gas is at this point. He just states that there is a plasma there. Composed of what? We don't know. He doesn't tell us. And so that plasma, that temperature, that environment has to be conducive to creating a plasma. Why is that environment there? What is that environment? And again, what is the mechanism? What is the magnetic field doing with specificity? Is it static? Is it moving? What is it?
Beleza. E
Perfect.
Esse plasma, quando ele está aqui na parte de baixo, ele tá gerando a luz que a gente vai observar aqui dentro do nosso planeta.
Oh, real quick. I don't know. I've seen Sovereign. I've seen you around, I think, in my on my streams. Thank you for watching, by the way. If you know Flatzoid, I would love to have a conversation with him. On whatever platform you want, he would be amenable to doing. I don't want to debate him. I don't want to try to change his mind on anything. I would just like to understand his methodology or his manner of thinking. Why it is that he is rejecting conventional science, and what it is that he holds to in terms of determining what is true and what is not. Like I said, I would love to have a cordial conversation with him, very much like I did with Austin Whitsitt. Maya, welcome. He's a waste of space. I'm gonna go with you were referring to Flatzoid. He wants money. There's some. Yep. Yeah, I know. Yeah, that is one of the current theories ideas being passed around, is that he's a grifter. But I would like to interact with him myself. I would love to know. I would love to hear what he has to say about that, because before you speak to Flatzoid, first looked up 11 frames. What the? Okay. Yeah, I do know that he is religiously motivated. Sovereign says I can answer that because it is an actual science. I would love to hear it from Flatzoid himself, and again, I would love to have a conversation about it, because I would question what is his definition of actual science, and where did he gain that definition? Where did he learn that definition? And why is it that the source from which he learned it is the authority? Because I can tell you, the scientific consensus does not hold to that. So, oh, excellent. Thank you. Thank you, Sovereign. If you can make that happen, I would very much appreciate it. So, let me know if you want more details. I don't want to take your thinking, but Clive Wells seems to know. I will look into 11 frames. I think you're talking. I think I know what you're talking about. He edited a video where he extracted 11 frames because I think it was something like a boat was going over the horizon, and essentially he took out 11 frames, which showed the boat actually going below the horizon, so such that it only appeared to disappear out of sight. Is that what you guys are talking about? Yeah, observation, hypothesis, and experimentation. So, again, I would love to have a conversation with him. I'm going to say that I would love to be a guest host on your show. If you ever wanted to tackle the Tychoism, or the geocentric universe, if you ever wanted to. All right. Anyway, let's get back to this dude. So, where is plasma? So, summing that up.
Ele está girando com uma rotação completa por dia, tá? Então ele está fazendo esse movimento aqui, uma rotação por dia. Então ele está com uma velocidade altíssima. Por quê? Porque esse nosso modelo aqui é enorme. Aqui tem todos os continentes aqui dentro, tem todos os oceanos, tudo. E ele está lá em cima, numa área enorme, e ele tem que fazer esse giro em 24 horas. Ou seja, o plasma ele tem uma velocidade enorme girando aqui em cima. O planeta, plasma ele tem uma velocidade por dia. Então ele está com uma velocidade altíssima.
The plasma rotates once per day.
Esse nosso modelo aqui é enorme. Aqui tem todos os continentes aqui dentro, tem todos os oceanos, tudo. E ele está lá em cima, numa área enorme, e ele tem que fazer esse giro em 24 horas. Ou seja, o plasma ele tem uma velocidade enorme girando aqui em cima. Então ele não fica esquentando uma só posição do domo, tá? Agora, o que entra aqui pra gente? Entra plasma dentro da nossa atmosfera? Não entra o plasma. O plasma fica lá fora, ele está sendo repelido pelo campo magnético da Terra, ok? A luz do plasma vem aqui por cima e o domo da Terra funciona como uma lente convergente, que vai convergir essa luz que está lá em cima. Isso aqui é um laser de plasma, ok? Para vocês terem uma ideia, tem um laser aqui em cima, tem uma lente que está convergindo a luz do laser para produzir essa feição amarela que a gente está observando aqui, tá?
So again, I am going to admit my ignorance. I know that plasma lasers are a thing, but I know next to nothing about them. I don't know how they're generated, how they operate, or what happens. Eric, what are his qualifications regarding plasma physics? I don't think he has any. What I find to be interesting about this entire video is this is a geophysicist who, if you listen to his testimonial, will remind the audience that he is in fact a PhD geophysicist many, many times. He is a geophysicist putting forth a model of the Earth, and yet he does not discuss geophysics. Not once in this video does he discuss geophysics. The closest thing he gets, and I guess maybe you can consider this geophysics, the closest thing that he gets to geophysics is the Earth's magnetic field. Let's take a look at this. What are his qualifications regarding physics? You'll have to take that up with the University of Sao Paulo. They're the ones who taught him. They're the ones who awarded him a PhD in geophysics. So what he is stating here is that the plasma that is spiraling around spiraling above the dome, that light will then enter through the dome, and the dome, because it is curved, will act like a lens, and then the focal point of the dome's basically the focal point of the dome is where the sun is located. The sun is not a big ball of plasma. It is focused light. There you have it. So many questions. One, if you look at that diagram that he's showing you, it would seem to indicate that the light from the plasma is coming in from the top. So, which would indicate effectively the North Pole on his already established flat Earth model. And as he will show in a moment, that's not where he is placing the sun. So, granted, you can move that model if you assume that the Earth, or if you assume that the Earth is if you assume the dome is in fact spherical, then obviously you can adjust that so that the light comes in from there. Science, is this guy faculty somewhere? I have not been able to deduce that, but I haven't looked rigorously. He seems to, the last thing on his CV that I found is that in 2008, he seems to have transitioned into small business something. Building a small business. I guess maybe even teaching people how to build a small business. I don't know. His last publication that has been featured is around 2012. So I don't know what he's been doing with himself for the last 10 years. I don't even know if he's still in Brazil. So, question. All right. So he seems to, one of the other things that I like to tell my students is that light is effectively the transportation of energy from one location to another. So this is energy. So the light, which is being generated by this plasma, he is stating that the rays that you see in that diagram are rays of light which are being created by the plasma. So unless he is going to claim at some point that light operates differently, then what you're looking at are streams of photons, each carrying a certain amount of energy corresponding to a temperature of at least 1 million Kelvin, passing through an ice dome without melting it, and then coming into a coming into a sharp focus, which then becomes the sun. And then presumably those, as if you look at that diagram, and maybe the diagram is not fully representative, because he doesn't talk about what happens to the photons that go beyond the focal point. If you look at the way that simple optics works, is that the light rays will come into a focus and then diverge away from that focus, which is why if you change the focus on a telescope that is in focus, the object becomes out of focus and not invisible. The light is still there, it's just not, it's more dispersed and cannot be seen as well or as properly. So, yeah, where does the plasma go? Where does the plasma light go out of the bottom of the sun, unless it doesn't? Again, he doesn't state this. The sun does have magnetic fields, Eric, and which he has no explanation for. He has claimed that H-alpha images are fake, so I would not be surprised if he claims that the sun does not actually have magnetic fields. Or I can easily see him saying that, yes, the magnetic fields of the sun are actually the focused geomagnetic fields of the Earth. Or the magnetic fields of the Earth. Geomagnetic field would be redundant. I don't know, but that's what he claims the sun is. The sun is focused plasma energy that originates from above the dome somehow manages to go through an ice dome, a literal water ice covering, without melting it. It gets a little weirder.
Então, aqui você não está vendo os raios de luz chegando, mas eles estão chegando de todas as posições aqui por causa de uma lente. E só me arrumar aqui um minuto. E basicamente você está vendo agora só essa parte amarela. Aqui é a mesma coisa. A gente tem o domo terrestre, seria o equivalente, uma lente convergente. A luz do plasma está em cima, só a luz passa pelo lado de baixo, o plasma não, o plasma fica lá em cima. A luz passa e o domo vai produzir um ponto de convergência, um ponto focal, que é a mesma coisa.
So, the plasma doesn't go through, but the light does. He seems to be implying that the light holds no energy capable of melting the dome. Interestingly enough, this actually has implications, because he does not specify, again, if memory serves, he does not specify where this focal point is above the Earth. However, if we assume that the dome is a sphere, if you can give a proper diameter of the Earth, basically the diameter of the bottom portion of the dome, you can then figure out where the focal point of the dome would be, and that would give you the height of the Earth, or height of the sun, or the distance of the sun from the dome, and from there I suspect you could do some simple geometry and get the height of the sun in this model. He, of course, does not do this in this video.
O que está acontecendo aqui. E esse ponto focal dentro da nossa atmosfera é o que a gente enxerga como Sol. Okay? Então o Sol que a gente está vendo, ele não é uma bola exatamente de fogo, ele é o ponto focal de uma luz que vem de...
And not for nothing, this ball of, or this focused light emanating from a plasma apparently is not hot enough to photoionize all of the atmosphere around it.
Em cima do domo.
Sharky, welcome.
A gente
Howdy.
não consegue
He is a flirt.
ver os raios de luz chegando
Or
e formando
flat
um ponto
earther.
focal. Da mesma forma que aqui a gente não consegue ver os vários raios de luz chegando e convergindo no ponto focal. A gente consegue ver só o ponto focal. Ok? Aqui é a mesma coisa, a gente consegue ver este ponto aqui, que a gente chama de Sol. E esse Sol está dentro da nossa atmosfera, ele é o ponto focal. Ele está longe o suficiente da cúpula para não derreter a cúpula. Ok? Mas, por outro lado, ele transforma tudo que está dentro da cúpula num estado que ele permite a gente estar recebendo esse calor, ter atmosfera, né?
So, this focal point of light transforms everything inside the dome in a state allowing us to receive heat and have atmosphere. So somehow, this focal point of light has created the gas which constitutes our atmosphere. That might be an assumption. Maybe he's talking about, instead of having an atmosphere, he's talking about structure within the atmosphere. But he does seem to indicate that it does provide heat, well, obviously, but apparently not enough heat to actually ionize or affect the atmosphere in any applicable, in any appreciable way.
E tudo mais. Ok. O padrão
Georg,
de dia e noite neste modelo do plasma.
This is where it gets weird.
Aqui, que o pessoal inclusive empresta a figura dos movimentos orientais, tá? Por quê? Porque o plasma, quando ele passa pelo domo, ele não vai funcionar simplesmente como muitos modelos da Terra plana mostram, ou seja, uma bola de luz aqui, iluminando como se fosse uma lanterna. Por que não? Porque se você iluminar só um trecho com o Sol aqui, você não conseguiria explicar a luz no planeta. Com este formato aqui, aproximado, a gente consegue explicar a luz no planeta. Essa cauda é a cauda do planeta.
Okay, so he is stating that the day-night cycle of the Earth is in fact a yin-yang symbol. That the illuminated portion of the Earth by the sun looks like a teardrop. This is demonstrably not true. I will leave it to someone who has more time than me to debunk the shit out of that. What I find to be interesting is he is stating that this focal point of light, which is not plasma, he is very clear on that subject. The sun itself is not plasma, but the light shed from this point has a plasma tail. Not assume I have no idea how that is even possible. Again, as by his own admission, or by his own instruction, shall we say, he has told us that the definition of a plasma is a high temperature gas. He did not tell us how high, but I can tell you that a corona, the corona of the sun, which is considered to be a plasma, is 1,000,000 Kelvin. He is stating here that there is the atmosphere where in this tail, that is where the Earth is still lit, is a plasma. That atmosphere, again, he doesn't specify the temperature needed to be a plasma, but by conventional science, that atmosphere must be at least 1,000,000 Kelvin. Sure. Okay. Also, a plasma tail, this gets me into thinking about comets. So a comet has two different types of tails. Because it is getting late, I'm not going to get too far into it. It has a dust tail and it has an ion tail. The ion tail is where you have electrons which are freed from the cometary nucleus due to sublimation. They couple to the magnetic field of the sun and are pushed backwards, pushed straight back away from the comet. So if you see a comet, you see that blue ion, straight ion tail, you can quite literally trace that back, a straight line, right to the sun. That would indicate, so for an ion tail, which I'm going to go out on a limb and say a plasma tail would work very similarly, it needs to be moved by something. It needs to be created by something. A magnetic field in this case, which, again, he has specified the magnetic field is at and above the dome. He hasn't, presumably it's also inside the dome, but if memory serves, he does not explain what physically causes the tail. Yeah, that would be great. The other issue, he's going to talk about the moon in a second, and this is where I think I only got through about 22 of the 27 minutes, because he seemed like he was wrapping up. But let's
plasma, tá? A gente tem um ponto focal, mas a gente ainda tem um pouco mais de luz, que é essa cauda do plasma, tá? Então a gente observa o dia e a noite nesse formato. Então esse formato que o pessoal lá das religiões orientais usa, etc., yin, yang, na verdade é uma observação física do modelo de iluminação da Terra, tá? Basicamente seria isso. A Lua aqui, no caso, no meio aqui da noite, né, ela não precisa estar no meio da noite, ela pode estar em qualquer lugar. A Lua não é exatamente uma bola de pedra viajando aqui dentro. A gente vai falar sobre a Lua, é mais complicado, mas a Lua ela vai ser usada para explicar por que existe uma zona mais segura na Terra, uma zona de latitudes, tá? Neste modelo aqui, isso aqui é um modelo.
One second. Sorry, I was looking at.
Aqui está o Sol.
Sorry, I was distracted from the video by from what Sovereign was saying. He emailed Flatzoid. Sovereign will be live at 9:35 if you'd like to join. I'm assuming that you mean 9:35 Eastern time. Sadly, I cannot join, and actually I'm going to have to wrap this up pretty quickly, is because, as it happens, and I can't give too many details away, George Mason will soon be George Mason will have. We are involved in deploying a satellite, and so tonight we are going to be doing preliminary observations of a geostationary satellite, the Ascent satellite specifically from the Air Force. That's a CubeSat. We're going to do basically a proof of concept. We are going to determine whether or not, or how effective our telescope is in terms of being a ground station for this satellite mission. Now, because of the fact that it has not been publicly released yet, I can't go into any details as to what the mission is, but I need to go in about 15-20 minutes at the very least in order to go help facilitate that that project. So I'm hoping that the university will get its act together and actually announce it, because I am very excited about this project. And while it may not seem all that cool to a layperson, for me it is fucking fantastic. It is vital in terms of our understanding of the basics of how we take measurements. So anyway, so let me back this up, because this is the part where I think I stopped paying attention when I first watched the video. This is where he talks about the moon. And he says the moon is not exactly a ball of rocks. It isn't a ball of rocks. It's a ball of rock and metal. But he does say that the moon can be anywhere.
No meio aqui da noite, né? Ela não precisa estar no meio da noite, ela pode estar em qualquer lugar. A Lua não é exatamente uma bola de pedra viajando aqui dentro. A gente vai falar sobre a Lua. É mais complicado, mas a Lua ela vai ser usada para explicar por que existe uma zona mais segura na Terra, uma zona.
I'm not sure. Again, this is definitely a translation issue. I'm not sure what SAFFEST zone is. Safest zone. If it does, in fact, if he did actually say safest, then it seems to imply that the moon somehow protects us from the radiation of the sun, or this plasma tail.
De latitudes, tá? Neste modelo aqui, isso aqui é um modelo, e aqui está o Sol. Ok, beleza. Então isso aqui é o padrão dia e noite. Algumas pessoas vão perguntar o seguinte: mas se a Terra é plana, como é que tem dia e noite? O Sol não deveria iluminar toda a Terra plana? E a resposta é não, né? Para quem já conhece o modelo Terra plana, isso é muito bem respondido em vários experimentos, mas olha só, aqui a gente consegue ver claramente que o Sol ele está iluminando essa parte da cidade, ok? Que a gente pode chamar de dia, e já não está iluminando essa outra parte aqui. Foi uma foto muito feliz. Por quê? Porque você já tem a noite.
I am going to. Well, obviously that's redundant. I am actually saying something, but I'm not going to explain the reason for that picture. Which to me is rather ironic.
E o dia, você consegue observar a noite e o dia. O que acontece é, assim como uma vela consegue iluminar só um pedaço da sua casa, esta grande vela, que é a luz do Sol, ponto focal da luz do plasma, ela consegue iluminar um pedaço da Terra. A Terra é muito grande. Ela tem todos os continentes, todos os países.
The Earth is very big. Well, how big is it? He doesn't actually specify.
todos os oceanos lá dentro. Por mais que o Sol seja muito forte, ele não consegue iluminar
it was deleted? Interesting.
todo o planeta de uma vez só. No futuro, ele vai conseguir iluminar sim, tá? A gente vai falar sobre isso neste modelo. Esse modelo explica. Depois que houver todo o problema da inversão do campo magnético da Terra, sim, a gente vai ter só dia, não vai ter mais noite, tá? Isso inclusive está previsto na...
This is where he mentions the Bible, which is why I suspect that his motivations for becoming a flat earther, someone who follows the flat Earth model, is divinely inspired. I believe his religious worldview is motivating his going forward. But yeah, so apparently. The sun is, what I found to be interesting is...
A luz do plasma, ela consegue iluminar um pedaço da Terra. A Terra é muito grande. Ela tem todos os continentes, todos os países, todos os oceanos lá dentro. Por mais que o Sol seja muito forte, ele não consegue iluminar todo o planeta de uma vez só. No futuro, ele vai conseguir iluminar sim.
Okay, so... This I find to be interesting, is that he's currently claiming that the sun does not put out enough light in order to illuminate the entirety of the Earth. However, he does state, in the future, it will be capable to illuminate for sure. We will talk about that in this model. This model explains.
Sim, tá? A gente vai falar sobre isso neste modelo. Esse modelo explica. Depois que houver todo o problema da inversão do campo magnético da Terra, sim, a gente vai ter só dia, não vai ter mais noite, tá? Isso inclusive está previsto.
Maybe I missed it in Revelation, but I don't remember the sun going out in Revelation, although I could be very, very wrong. Revelation is something of a fever dream, and I generally don't read it too often, so...
Isso na Bíblia. E esse modelo, o modelo que a gente está falando aqui de Terra plana, esse modelo explica isso muito bem, né? Aqui tem mais uma explicação, né? Porque a gente não vê o Sol,
Yep,
né? A gente
you
não vê
guessed
uma bola
If you have this on your bingo card,
assim, quando
you
já
win.
ficou noite, né? Você tem a questão de... Exatamente essa questão aqui, você perde de vista no horizonte as coisas, qualquer coisa, o Sol é uma delas também, né? E aqui está uma lanterna e uma vela mostrando exatamente que, olha, a vela, por mais que ela esteja bem aqui, ela não está iluminando ali atrás. Por quê? Ela só está iluminando aqui, a parte de baixo. Por que isso? Porque ela tem uma potência, ela tem uma capacidade de iluminação que não é infinita, né? Se eu acender um...
So yes, he is explaining the reason why we cannot see the sun because of perspective. The sun is simply just too far away. What the problem with this argument is that, and he points to these pictures as evidence of what he's talking about. And in those pictures, the candle is not bright enough to illuminate the background. The flashlight is only able to illuminate a small portion of the floor. That has to do with the contrast and brightness of the image. It has nothing to do with reality. I would put in serious money that if you're in the room where those objects were and look at the surroundings, they would look far different than if they would in that picture. This is verging on the ridiculous that he does not understand this, or that he's using this as an example. The other issue is, while it is true that if the sun were not visible, while the sun is not as bright as conventional science would claim, it would still be seen. It is a bright object. So simply perspective will not, since in this model, you're talking about the sun does not rise nor set. There is nothing blocking the light that is streaming through the air. that light still exists. That light still reaches your position. Therefore, you should be able to see it. Now, if it's far enough away, inverse square law, sure. Let's imagine a situation where it's so far away that inverse square law, it would be so faint as to be imperceptible by the human eye. We have telescopes. Why can't we see it using a telescope and a camera? So yeah, he goes to this.
Uma vela
I was
aqui
disappointed.
E o universo inteiro fosse plano, eu não ia conseguir enxergar a vela a 1 milhão de quilômetros de distância. Por mais que eu colocasse ela bem alto, não conseguiria. Tudo tem uma potência, o Sol tem uma potência também, tá? Ok. Sobre as estações do ano, todo mundo já conhece.
Okay, this is new to
é
me.
muito fácil de entender.
I may not go through all of this.
O Trópico de Capricórnio, ok? O Trópico de Câncer, né? A linha do Equador está aqui entre os dois.
I predict that he is going to talk about the fact that the focal point of the sun, the focal point that is the sun, moves relative to both tropics.
Né? Essa linha preta, mais ou menos, é a latitude segura, que a gente vai falar mais para frente. A gente vai falar bastante sobre essa latitude segura no modelo de inversão de campo geomagnético.
There is only roughly 4 minutes left into this video, so in that he's going to talk about theoretically the geomagnetic field inversion and how that produces a quote-unquote safe latitude.
E a questão das estações do ano funciona assim. A luz do Sol que está passando, está girando nessa terra plana, nesse mapa de terra plana, tem um momento que ela está mais perto do Trópico de Capricórnio, em outros momentos do Trópico de Câncer. Ela faz um movimento espiral que vai chegando perto do Trópico de Câncer e depois vai voltando para o Trópico de Capricórnio.
Spiral
Quando
motion.
está perto do Trópico de Capricórnio, a gente tem o verão aqui no hemisfério sul, vamos dizer assim, no hemisfério sul, Brasil, aqui a África do Sul e tudo
Assuming
mais.
the quotes were
Quando está
southern.
mais perto do Trópico de Câncer, o verão está na Europa, Estados Unidos e tudo mais, e o inverno está no Brasil. Tá? Basicamente, essa é a explicação para as estações do ano.
Hey, go me.
Agora, uma revisão geral. A palavra-chave do dia é o plasma. Tá? O plasma, então, estaria acima do domo. O domo seria um domo de
Just like any good scientific presentation, you got your conclusion slide. I approve. That's actually not. I'm not actually being sarcastic. Conclusion slides are very nice to have in a scientific talk.
de água congelada, né, gelo, bem transparente. Esse plasma ele tem um movimento espiralado e fica fora do domo. A gente não tem contato com ele. Simplesmente a luz do plasma, ela entra pelo domo e depois o domo funciona como uma lente convergente, vai gerar um ponto focal que é tão forte, quando a gente olha para ele a gente vê o Sol, tá? O
Yes,
Sol,
Cherokee.
ele é um fenômeno óptico, ok? O domo é feito de gelo puro. Ele não derrete, pois o campo magnético da Terra repele o plasma, ou seja, o plasma ele nunca vai tocar o domo enquanto o campo magnético estiver forte. O plasma está para cima do domo, então ele não consegue derreter o domo terrestre. E além disso, ele está girando com uma velocidade enorme, porque o domo é gigantesco, e ele não concentra energia num só ponto do domo terrestre de gelo, tá? Então ele não derrete o domo, né? O próprio domo é criado ao longo dos anos pelo campo geomagnético da Terra, o qual mantém as águas de cima. Ok. Então a água é diamagnética.
So he just said that the dome was created over years. That was not something that he said in the earlier part of the video, in the sense that, because that was one of my questions, whether or not this was an ongoing event. He basically said that the plasma or the the magnetic field created the dome, but he did not specify a time frame as to how the dome was created or when the dome was created. So now we at least know that in this model, the dome, there is a certain amount of time over which the dome was created, which has the implication of there was a period of time on the Earth where the dome did not exist.
Magnética, ela sofre repulsão pelo campo geomagnético e essa água foi parar lá em cima e gerar esse domo exatamente por causa disso, ok? São as águas de cima.
Eric, if you could DM me that, DM me that link, maybe I'll take a look at it later on.
O Sol que vemos é o ponto focal de luz do plasma, né? Que sofre convergência no domo, que funciona então como uma lente convergente. Apenas a luz do plasma atravessa o domo, o plasma não. Basicamente é isso por hoje. Esse é o primeiro passo para a gente entender o modelo que vai vir depois, todas as outras coisas.
Howdy.
Mas basicamente a gente tem que entender então que o domo ele é de gelo, neste modelo aqui. O plasma está lá em cima, ele não está entrando na nossa atmosfera. A gente simplesmente consegue ver o Sol exatamente porque o domo funciona como uma lente convergente. Basicamente é isso por hoje. Por hoje é isso. Muito obrigado.
So there you have it, folks. That is a PhD geophysicist explaining his flat Earth model that he believes explains all questions with regards to how the Earth is and how the Earth operates. In that video, he expressed not once but twice that he would be talking about a magnetic inversion model. He does not say that in this. He does not talk about that at all in this video. So hopefully, what I will do is I will try to track that down to find out exactly what that means. I'm very, very particular, or very, very curious on what he means when he refers to a safe latitude. Because again, this is being translated. There could be a transcription error or translation error. He also seemed to indicate that the moon creates a safe zone. Safe from what? I don't know. Presumably, from context, I think that it is safe from the sun. But what is harmful from the sun? What is about his model of the sun would create danger? So I don't know. Turing test, howdy. So I saw this and I thought I had to talk about it. I have been accused lately of not exploring more alternative theories to alternative cosmologies. So I hope to change that. Speaking of which, and again, I will be going very, very, very soon. Did you guys like this sort of thing? Did you like me going through basically live a video of talking about a cosmological model? And because what I'm thinking is, in the previous stream, in the stream 2 days ago, I talked about the neo-Tychonic model as subscribed by Simon Shack, and I talked about how I was going to dive into it through a series of edited videos, and I've come to realize that I can't do that. I do not do editing well. It takes up a lot of time, which I don't have. I'm not particularly interested in editing, which makes me postpone it. So what I'm thinking that I want to do is what I want to focus on is doing live streams where I talk about these models that have been put forth and give my thoughts on them. I don't plan on I'm not going to approach this from a Simon Dan or a Dave McKeegan perspective in just simply stating how they're wrong. What my goal would be is, as I've stated to flat earthers many, many times, is if you're going to create a model that you want to convince me of, not just convince yourself or your colleagues of, but you want to convince me, a member of the conventional science consensus, if you want to convince me of it, then one of the things to consider is that any model is going to have implications. These implications are what lead to testable, experimental things, lack of a better term. So, for example, the one I gave was that if this model is correct, then if the model is correct and the sun is simply a bright point from focused plasma light, whatever that is, then based on a size of the Earth, a diameter of the flat Earth, or at least a diameter of the base of the dome, you can determine the radius of curvature of that lens, and you can then figure out how far away from the dome the sun is. And from there, I am fairly confident you can determine how far away the sun is from the ground. That would give a quantifiable measure to your model that can be tested. If we are going to talk about what is and is not science, if we're going to talk about of what distinguishes something from a science from a pseudoscience, I think we can all agree that it needs to be testable. We can disagree as to how or what a test is, but I think we all agree that science is testable. And so what I would like to do is I would like to look at these models, not in a this is how they're wrong perspective, but in looking at it through the lens, pun intended, through the lens of figuring out what the implications are of the model if it is true. And I hope that these insights would be, I hope that someone would find these insights to be entertaining. Definitely, I want them to be interesting. And I'm hoping that they will be provocative enough that someone from the flat Earth side will be able to explore this in more depth. Because I am now of the, we have talked about, particularly with I Can Science That, and actually in this chat as well, when we're talking about Flatzoid, there have been accusations of people being grifters. There have been accusations of being liars. I have my own personal opinions on those things. I am setting those aside for these videos. I am not going to accuse anyone of being a liar. I'm not going to accuse anyone of being a grifter, and I am going to treat them as if they are approaching this honestly. And so, here it is. One of the complaints that I heard back when I first started this, first entered into this this whole thing back in 2018 or so, was that people who are science skeptics, particularly of flat Earth, were upset that someone from the scientific community would not engage with them. I think I have shown in the past my willingness to do so. These videos are now my direct attempt to engage with you. If you see these models, I'm not suggesting you agree with these models. I am not subscribing these models to you. I am saying that this is a model that a flat earther has created and is presenting to be factual. I am going through it with a critical eye, and I am going to tell you my opinion as to the implications that could potentially be tested from this. And I would really hope that this will spawn some kind of conversation within the flat earth community, because, again, science to me, and maybe this is something we disagree on, science to me is curiosity. Science never accepts something as being settled. We are always pushing to answer more questions. And if the flat earth is stating that they are scientific, then I would imagine they would have that same curiosity. I would imagine they would want to look at this and see for themselves whether or not this model is actually true, if this model can actually work, or if parts of it could be incorporated into their own. Because I can tell you right now, the spiralicity of that plasma seems to work really well, or seems to fit really well into the aether cosmology construct. So if people want to discuss this, what I'm hoping to be able to do with these videos, again, if people want me to do this, I'm actually kind of excited about this, is I want them to talk about it. I want them to have discussions about it. I want them to be open to input from folks like myself, folks like Clive, like PhD Tony. I can science that, and allow us to basically help with that conversation. So, all right, with that being said, let's see. Toss the benefits of a long education just to ride Dupé's coattails. Magnetodome. Yeah, that's got to be a movie. That's got to be a movie somewhere. How do we have clouds? As you've probably saw, he doesn't specify. What's the verdict on this guy? Guilty as charged. I don't know exactly what you mean by that, Clive. Do I believe he's a Poe? No, I don't believe he's a Poe, which makes it even more intriguing to me as to how he can divorce himself from what he has learned and what he has used in practice for it. Although, as Tony points out, I don't know exactly what he was talking about in specific. At least in astronomy, you can assume, if you were trying to work out the particulars of a stellar atmosphere, it is more, at least back in my day, it was done assuming a flat planar geometry, because adding a third dimension is problematic. It's very hard to do. At least it's very hard. It's very expensive from a computational standpoint. So it is possible that his seismological work was all basically assuming that the Earth was flat, but I digress. My interest, again, is I don't think he's a Poe, so I'm curious as to why he has gone down this road. So do I think he's a grifter? I have no evidence of that whatsoever. Sharky and Craig always said, no, not one physicist is a flat earther. This guy has apparently broken the mold. Yeah, so there are... Yeah, this is the first physicist that I'm aware of whom I've heard speak who is a flat earther. Robert Lyle and Robitaille are geocentrists. They and Sungenesis and Bennett, they are not flat earthers. They are simply geocentrists. As to his channel, like I said, this particular channel is old. This video that I've gone over is 5 years old. He has 4 subscribers on this. I think Eric had said that he had a previous channel that had gotten deleted, that had over 200. So I don't know if he even subscribes to these beliefs anymore. I don't know what his current ideology is when it comes to the shape of the Earth. But as someone pointed out before, I mean, this was brought to my attention by Taboo Conspiracy. I don't know how much traction he's going to get within the flat Earth community, but I wanted to put in my 2 cents. If this video or ideas that stem from this individual propagate throughout the flat Earth community. So, all right, like I said, I've got to go. I've got to generate some flat fields, and I've got to eat. Or not flat fields, finder charts, and I've got to eat. Thank you all for being here. If you've been here, thank you all for being here at any moment, particularly those who have been here the entire, 2 hours, 24 minutes. You guys are the best. You guys are you guys are just fucking awesome. I am Professor Parks, PhD, and I make content on astronomy, science skepticism, and mental health. If you like that sort of thing, if you like that sort of content, please consider like, share, and subscribe, and hit that bell for notifications, because I'm a chaotic son of a bitch, and I do not post regularly. And I also will postpone streams because of my day job. And so definitely hit that bell for notifications, like, share, and subscribe. If you wish to help support the observatory financially, please consider becoming one of my Patreons. All monies from Patreon go to helping the observatory buy anything from incidentals like power supplies, lights, to larger ticket items like our new planetary camera. If you'd like to help me out financially, put money into my little grubby hands, please consider becoming a channel member for that. I would very much like to. One of the hurdles that I have is justification for taking time out of my day to make these videos. I want to make them, but I also have a day job, which is demanding to a certain extent, and also chaotic in its scheduling. So having a monetary motivation would be very helpful for me. So I'm definitely in this for the money. At least, obviously for some part. So if you want to consider me a grifter, I'm guilty as charged. So anyway, with that being said, I hope you all have a great night, or a great day, or a great morning, wherever you happen to be, to paraphrase one of our favorite flat earthers. As for Flatzoid, please, I am sincere in wanting to have an honest, civil conversation as to why it is you have rejected conventional science, what your definition of science is, how you arrived at that, and what sources you are using to justify your current ideas of science. I can't make it to your live stream tonight, which apparently, for you folks, if you're interested, apparently Flats is going live in about 5 minutes. So do with that with whatever you will. And I am now going to stop rambling. So, with that, peace out and clear skies.